Hi everyone, welcome to goclasses. In this session, we are going to study Relational Algebra Complete Summary. Remember, this will be complete summary and comprehensive summary of Relational Algebra. So after watching this complete summary, you can solve all the GATE previous year questions from Relational Algebra topic. Okay. So if you did not study Relational Algebra so far, then also this complete summary will help you solve all the GATE previous year questions from this topic Relational Algebra. Okay, so let's start now. So let's see what is relational algebra. This relational algebra, this is a theoretical query language for relational database model. Okay, very simple. Remember this relational algebra, this is a theoretical query language. This is a query language means we want to retrieve the data from the database. In database, the data that you have stored, okay, we want to retrieve that data. So this relational algebra, this is a theoretical, or I can say mathematical, or I can say formal query language for relational database model. Okay, so now let's see the recap of relational database model. What is this relational data model? Let's see this. So you already know that in the relational data model, the database is collection of tables. Yes or no? The database, that is collection of tables. Every table is called a relation. Okay, and in a table, what you have? So in a table, you have attributes and you have tuples. Okay, so you can see, for example, this is a table. On your screen, you can see this is a table. This is the table name. You can see table name is product, and these are the attributes, or I can say column names, or I can say attribute names. So you can see name, price, category, manufacturer. These are the attribute names. And you can see these are the tuples, or I can say these are the records. So remember, you can call it rows, or you can call them tuples, or you can call them records. This is the actual data. Okay, very simple. So this is the idea that database is collection of tables. Every table is called relation, and in a table you have attributes, or I can say columns, and there are tuples. Tuples means these are the records. Okay, this is the actual data, I can say tuples. You can call it row, or you can call it tuples. Now you already know that every attribute has a domain from which it can take values. Okay, every attribute, for example, this attribute has a domain, I can say character string. Okay, this attribute has a domain, I can say integer, or I can say real number. Okay, real number. So very simple, every attribute has a domain. And remember, domain is set of atomic values. I can say every domain, remember, every domain is set of atomic values. Okay, so all these things you already know. So this is just a recap of relational model. You can see this is another table, this is another relational database model. Okay, table, and you can call it relation. Every table is called relation. You can see these are the attributes. Okay, these are the attributes, and these are the tuples. Okay, very simple. Now, so let me tell you that this is called schema. Okay, you can see this is students table. The name of the table is students. The name of the table is students. So here, let me tell you one thing, that this entire thing, including the domain, every attribute has a domain, right? This entire thing, this is called schema. This is called schema. And remember, these these tuples, okay, this is called instance. So very simple point, that these tuples, or I can say these records, these are called instances. And remember, this entire thing means, I can say table name, attribute names, and their domain. Okay, this entire thing is called schema. So this is the difference between schema and instance. Okay, what is instance? This is the actual data. I can say this is the actual data content. And what is schema? This is, I can say, the structure of the table, the logical structure of the data. So you can see in this table, you can see what is schema. So let's see what is schema. In schema, you have name of the table, okay, and name of the attributes, also the domain of the attributes. So these three things, they create schema, and this is your instance. Okay, now, so you can see here, for example, in your database, let's assume there are three tables. Okay, these are the three tables. So this is schema, because schema is logical structure of the data. In your database, what is the structure of the data? So you can see in your database there are three tables. These are the three tables: user table, group table, member table. Okay, so you can see in a schema what things are there. So in a schema, you have table name, okay, you have attribute name and domain name. So these three things, they create the schema. Very simple. And you can see this is the instance. Instance is the data. For example, look at the member table. This is your member table schema. Okay, this is the schema of the member table. And this is the data, or I can say this is the instance. You can easily see in the member table there are two attributes, uid, gid. There are two attributes. So you can see that these are the tuples, uid, gid, uid, gid. Okay, so these are the tuples. You can see this is tuple number 1, this is tuple number 2, and so on. Okay, very simple. So this is instance. Okay, and you already know that every table that is a set of tuples. Yes or no? So tell me, order of tuples matter or not? Order of tuples, does it matter? The order of tuples, that does not matter, because remember, every table is a set of tuples, and in a set, order does not matter. And tell me, because it is a set of tuples, every table is a set of tuples, so is it possible you can have duplicate tuples? Is it possible two tuples can be exactly same? It is not possible, right? Because in the relational data model, every table is a set of tuples. So in a set, the order does not matter. Also, duplication is not allowed. Okay, very simple. Now let's see what is a query language that you already know. Query language means basically we want to retrieve the data from the database. Okay. Now remember, there are some query languages. There are theoretical query languages and there is practical query language. Theoretical query languages, these are two type of theoretical query languages are there. One is relational algebra that we will study in this lecture. Another is relational calculus. Okay, there are two type of relational calculus. One is tuple relational calculus, TRC. Another is domain relational calculus, that is DRC. Okay, so very simple. There are two theoretical query languages, I can say. One is relational algebra, another is relational calculus. These are the two theoretical query languages. And this is practical query language, that is SQL. Okay, this is practical. All are retrieval. Remember, all of them, these are query languages, means the data that you have stored in your database, we want to retrieve that data. Okay, very simple. And all these query languages, remember, whether you have relational algebra, relational calculus, or SQL, all of them, they work on relational DBMS. They work on relational database model. Okay. Now, we will focus on relational algebra. So now let's see relational algebra, procedural versus declarative. What is the meaning of procedural language? What is the meaning of declarative language? And let's see this relational algebra. This is what type of language, whether it is procedural or it is a declarative. So let me tell you that relational algebra, this is procedural language. What it means, the name itself is telling you. Procedural means in the relational algebra query, we specify step by step, we specify step by step process to get the result. Okay, very simple. Remember, this in the relational algebra, we specify step by step how to get the result. And in the declarative language, what we do, we just specify what we want. We don't specify how to get the result. Okay, this is the difference. So let me tell you the difference between procedural language and declarative language. So let me tell you. First of all, let me tell you that relational algebra is procedural, that is not declarative. Okay. Now, what is procedural and what is declarative? So let's see. So let me tell you, declarative language means in this declarative language, we specify what we want. Okay, we specify what we want without specifying how to get it. Okay. But in the procedural language, we specify what we want and also the steps to get the result. Okay, this is the idea. SQL is declarative and relational algebra is a procedural. Let me give you one analogy. You can see this is the analogy. This, if you want to make a cup of tea, this is your task, right? Okay, I want a cup of tea. This is the task. Now, in the procedural language, what we will do? We will provide the step-by-step procedure how to get this task done. Okay, I want to get this task done. So in the procedural language, I will provide step by step process how to get the task done. Okay, so you can see procedural language. Which is a procedural language? Relational algebra is a procedural language. In the relational algebra, we specify step by step how to get the task done. Okay, and in the declarative language, what we do, we just specify what we want. We don't care how to get the result. See, we will just specify get me a cup of tea. Now we don't care how the person will do. Okay, what are the steps taken to get this task done. We don't care. Okay, so this is the very simple point: declarative and procedural. Relation algebra is procedural. In the relation algebra query, we specify step by step process, the step by step procedure how to get the task done. Okay, in the declarative, we just specify what we want. We don't specify how to get the task done. And you can see SQL is the example of declarative. Okay, very simple. Now let's move on. So we have seen what is procedural and what is declarative. And remember, relational algebra, this is procedural. What this means? This means that in the relational algebra query, we specify exactly what steps to follow. Step by step procedure we specify how to get the task done. We specify the exact steps, okay, to use. Very simple. Now let's see some important points before we start relational algebra. These are important points, and some students they have misconception. So let me tell you the important points of relational algebra. Okay. First of all, this relational algebra, in short, I will write it RA. Okay. This relational algebra, let me tell you, this works on pure relational model. This works. Remember, this works on pure relational model. What that means? Okay, what that means? This relational algebra works on pure relational model. What that means? That simply means that these are the things. First of all, every table is a set. Yes or no? Okay, every table, every relation, or I can say every table is a set. Is a set. Okay, what it means? When I say set, what it means? It simply means no duplication of tuples. Okay, no duplicate tuples. There we don't have any duplication of tuples. No duplication of tuples. Two tuples cannot be exactly same. Okay, no duplication of tuples. Also, let me tell you, in the relational algebra, there is no concept of null. There is no null values. Okay, so remember, when you study relational algebra, you don't have to worry about null values. Okay, in the relational algebra, there is no concept of null values. Okay, so very simple. Your input table will not have null values. So these are simple points. There is no duplication of tuples, and you already know that there will be at least one primary, exactly one primary key. Yes or no? There will be one primary key. Okay, there will be one primary key. So these things you already know. Okay, very simple. So let me tell you that these are the rules for relational algebra. First of all, that every table is set of tuples. Okay, every table, that is a set of tuples. Set of tuples means duplicate tuples are not allowed, and the order of tuples does not matter. Order of tuples inside the relation, that does not matter. Okay, so very simple. And remember, there is no null values in the relational algebra. This is important because I have seen many students, they, whenever they are solving any relational algebra question, then they think about null values, then they worry about null values. Okay, they will put a comment on gate overflow that what if the input table has null values. So let me tell you that there is no concept of null values in relational algebra. You can see this is from a university. This, you can see this statement: there are actually no concept of null in the relational algebra. So remember, whenever you are solving relational algebra question, then you don't have to worry about null values. Yes or no? It is a good thing, right? Because null values, they can create trouble. Okay, in SQL we have seen that null values can create trouble. Okay, very simple. So you can see that there is no concept of null values in relational algebra. Okay, now let me tell you that you might be thinking, sir, in a relational algebra, we have outer joins. Yes or no? In the relational algebra, there is a concept of outer joins. This concept we have. And in the outer joins, there will be null values. Yes or no? The null values are inserted when we apply the outer join. Do you agree with me? Full outer join, right outer join, left outer join. So you might be thinking, sir, in a relational algebra, we have concept of outer join. And when we apply outer join, then null values will be inserted. Then why am I saying that there is no concept of null values in the relational algebra? Can anyone tell me? I am saying there is no concept of null values in relational algebra. Then what is the reason? So let me tell you very simple that outer joins, these are not considered part of basic relational algebra. These are actually part of extended relational algebra. Is this clear? The outer joins, they are not considered part of basic relational algebra. They are part of extended relational algebra. Is this clear? Also, one more thing. When you apply the outer join, remember the input table does not have null values. Okay, the resulting table, the final result, that can have null values, but the input table does not have null values. Okay, but the actually important point is that outer join, that is not considered part of basic relational algebra. Okay, so finally I can say that these are the important points, that relational algebra, this works on relational model. It means every table is a set. Set means order of tuples does not matter. There is no duplication of tuples, there are no null values, and there is one primary key in every table. Okay, so these are the simple points. I hope you understood. Is this clear? So tell me, if you solve the gate question of relational algebra, then will you worry about the null values? Let me know. Will you worry about null values? No, don't worry about null values, because there is no concept of null values in relational algebra. Okay. Now let's get started. Now we will see the operators and the syntax of relational algebra. We will see. Okay. So before that, let me tell you that in this relational algebra, what actually happens. Overall, what happens, let me tell you. In this relational algebra, overall, this happens that, see, you have query. Okay. This is your relational algebra query. This is the relational algebra query. And the input is what? What is the input? The input is tables. Yes or no? The input is tables. Okay, the input are instances, or I can say relations. Relation R1, relation R2, and so on. Okay, so remember, the tables are relations. And remember, output, what is that? That is also a relation. Okay, output is also a relation. So very simple. Okay, is this clear? And remember, every relation is set of tuples. So the input is also set of tuples, the output is also set of tuples. Okay, so let me write it here, that the input is also set of tuples and the output is also set of tuples in the relational algebra query. Okay, you do not have duplicates, remember, in the input also, in the output also, because the input is also set of tuples. There is no duplication of tuples. Okay, the input is also set of tuples and the output is also set of tuples. There is no duplication of tuples. Very simple. And the order of tuples does not matter. Okay, so all these things are very simple. This is overall the structure of relational algebra query. Okay, now let me tell you, if you want to become expert of relational algebra, then what you need to do, let me tell you, then you need to understand every operator clearly. Okay, we will see in the relational algebra what are the operators. Each operator we will study. Okay, so you understand each operator, and once you understand every operator, then what we will do, then we will write and understand this relational algebra queries. Okay, we will use the operators. So first to understand what is an operator. Okay, you understand each operator clearly, and then we will see how to use that operator to write relational algebra queries. Is this clear? Very simple. Now let's see algebra operators. In the relational algebra, what are the operators? So let's study that. So let me tell you that in the relational algebra, there are six basic operators. You can see there are six basic operators in relational algebra. These are the basic operators. One is select operator. This is the symbol for select operator. Project operator, symbol is pi. Cartesian product, symbol is cross. Set difference, symbol is minus. Union, symbol is u. And rename, symbol is rho. Okay, so remember, these are the six basic operators. Is this clear? These are the six basic operators. We will study each of them one by one. You understand each of them one by one, and then we will see how to use them to write relational algebra queries. Okay, very simple point. So let me tell you the overall overview. So the select operation, what it will do? This will select the tuples. This will filter the tuples. Okay. Project operator, it will filter the columns. It will select the columns. Cartesian product, it will join the two tables. It will join two tables, or I can say every tuple of one table will combine with every tuple of another table. I can say you will combine two tables. Very simple. Set difference, this is your set operator. Okay. Union, this is also your set operator. You will do the union of two tables. Here you will do the set difference of two tables, and here you will do the renaming of table or the attributes. Okay, we will rename attributes and the relation. So these are the six basic operations in relational algebra. Okay, but there are some more operations in relational algebra. There are some more operators, like we have intersection, we have natural join, we have division, we have theta join. Okay, and there are outer joins. Okay, so these are additional operations. Now tell me one thing. I am saying these are the basic operators, and here I am saying these are the additional operators. So tell me, are these not basic? What is the meaning of basic and what is the meaning of these additional operators? So let me tell you, these additional operators, these are derived operators. These are derived operators. What that means? That means these operations you can derive from the basic operations. Okay. So let me tell you one thing, that if you have these six operations, then from them you can derive these four. Okay. Is this clear? Very simple. So from these six basic operations, you can derive these operations. So that is the reason. Tell me, if I remove from the relational algebra, if I remove these facilities, then can I say I am decreasing the power of relational algebra? From the relational algebra, if I remove these facilities, then am I decreasing the power of relational algebra? The answer is no. Okay, because remember, what they can do, they also can do. Okay, from the basic operations, you can easily create these operations. Okay, so remember, these additional operations, or I can say these derived operations, they do not add any power to relational algebra. Okay, very simple. So overall, what we need to study, we need to study these six basic operations, then we need to study these derived operations. Okay, simple. Now let me tell you one more thing. Some operations are unary operations and some operations are binary operations. Unary operation means they will take one table and output will be one table. And some operations are binary operations, they will take two tables, output will be one table. Okay, is this clear? So remember, some operations are unary operations and some operations are binary operations. We will see which is unary, which is binary. But is this point clear, that unary operation means the input will be one table, output will be one table, and in the binary operation, input will be two table, output will be one table. Okay, remember basic operators, these are the basic operators: selection, projection, cross product, union, difference, renaming. These are the six basic operators. Okay, and remember, these are the additional derived operators, like join, natural join, intersection, and so on, division, and so on. Let's move on. Now we will study each operator one by one. First, we will study selection operator. What is this selection operator? So let's see this, understand this carefully. Selection operator, let me tell you the symbol. The symbol is a sigma. Okay, the symbol is a sigma. This is the name of this symbol, that is a sigma. This is small sigma, right? This is big sigma. This is big sigma, but this is small sigma. So remember, selection operator, the symbol is a sigma, or I can say small sigma. This is the symbol. Now, what is this selection operator? This selection operator, it will filter tuples. Okay, let me tell you what is the task. Okay, what is the task it will do? It will filter tuples. It will filter tuples based on a tuple selection condition. Okay, very simple. This will filter tuples based on a tuple selection condition. Tuple selection condition C. Very simple. So remember, the syntax is like this. Let me tell you the syntax. The syntax is like this, that you have this relation R. Okay, and what we are doing, we are selecting the tuples. We are selecting the tuples based on a condition. Okay, is this clear? This is the syntax. Overall, this is the syntax. So here what is happening? Here remember this C, this is a condition. This is tuple selection condition. Condition for tuple selection, I can say. This is condition for tuple selection. Which tuple we want to select? This is the condition for tuple selection. You can see this is your selection operator, right? Agree? Okay, this is the select. This is the selection operator. Selection operation. What it means? It means we are filtering the tuples, we are selecting the tuples, and this is your relation. Okay, so here what will happen? Here the result will be those tuples which satisfy condition C. Okay, yes or no? So very simple. Basically, what will happen? Those tuples which satisfy condition C will be in result. Okay. So I can say those tuples that satisfy, okay, those tuples that satisfy condition C will be in result, will be in the result. So very simple point. Okay, is this clear? Now, let me tell you one more thing. You can see, look at this selection operation. This is the condition, and this is one table we are giving. So you tell me, is this unary or is this binary? Let me know. Is this unary or is this binary? This is unary. Yes or no? This selection operation, this is unary operation. Okay, what it means? It means that in the selection operation, the input will be a table, one table. Yes or no? Input will be one table. Another output will be one table. Very simple. Okay. So, and remember what it will do? It will only filter tuples. Very simple. It will only filter tuples. It will only filter tuples. So the schema will not change. Yes or no? We are only filtering the tuples. Means the tuples which will satisfy the condition C, only those we will keep. The remaining tuples we will remove. Okay, so the schema will not change. Yes or no? The schema unchanged. The schema remains unchanged. Okay, but the data will change. So remember the R1, R2, their schema will be same. So let's see example. You can see this is your table. This is the user table. Now on this user table, I am applying this selection. This is the selection condition. You can see user table. This is the select operation, and this is the condition. Condition is POP, popularity is greater than 0.5. Okay, means remember, I want those tuples because this is tuple selection condition. Okay, this is your selection operation. So this will select tuples. I want those tuples where popularity is greater than 0.5. Okay, so remember this tuple. Let's check this tuple. Here popularity is greater than 0.5. So this tuple will be selected. This tuple will not be selected. This tuple will be selected. This tuple will not be selected. Finally, in the result, there will be two tuples. Okay, did you notice the schema is not changing? Yes or no? Did you notice schema is not changing because we are just filtering the tuples. The tuples which satisfy this condition will be selected, and the tuples which do not satisfy this condition will be removed. So the schema will not change. Is this clear? Very simple. So if this is your input table, you apply this query, then this will be your output table. I hope this point is clear. Let me know. Is this clear? Understood? Okay. One more thing. Remember this this tuple selection condition we will apply on each tuple individually, independently. Okay, this tuple selection condition, this we will apply on each tuple independently and individually. Okay, very simple. So you can see here. So this is your syntax. You can see this is the table, this is the selection operation, and this is the condition. And finally, you can see the tuples which satisfy this condition, they will be in the output. The remaining tuples will be removed. So can I say that selection operation is doing horizontal partition of the table? This selection operation, can I say it is doing horizontal partition of the table? Notice this selection operation, or I can say this sigma. I can say this is basically doing horizontal partition. It is basically doing horizontal partition of table. Okay, what that means? See, this means like this. This sigma CR. Okay, so here what will happen? If your input table is this, let's assume this is your input table, then you can notice the tuples will be divided into two categories. Can I say? Okay, can I say that on this table, if you apply this query, if you apply, then what will happen? Then I can say the tuples will be divided into two categories. Okay, one category will be those which satisfy condition C and those which do not satisfy condition C. Okay, you can see tuples will be divided into two categories. Those which satisfy condition C, those which do not satisfy condition C. Okay, so very simple. Here I can say C not satisfied, C not satisfied, and these are the tuples which C satisfied. So I can say that this selection operation, it is basically doing the horizontal partition of the table. I hope this point is clear. And in the output, what you will have those tuples which satisfy condition C. Yes or no? In the output, finally, I can say you will have these tuples, okay, which satisfy condition C. These tuples will go to the output. Simple. Okay, so this is the idea. Now let's see this. If this is your table and we apply this query, then what will be the result? So you can see from the student table, we are selecting tuples where GPA greater than 3. Okay. Remember this tuple selection condition we will apply on each tuple independently. So let's apply this on the first tuple. So this tuple will be rejected. Let's apply this on the second tuple. This also will be rejected. Let's apply this on the third tuple. This will be selected. Let's apply this on the fourth tuple. This will be selected. So finally, I can say that you can see the result of this query will be this. Okay. One more thing here. You can see this result we are basically assigning to S. Okay, this result we are assigning to S, so the result will have this name S. Okay, this is just a simple point, nothing here. Okay, nothing important here, but we are basically this result we are assigning to S. Okay, so you can see this is the result. Very simple. So we have seen this selection operation. Input is one table R. Okay, so this is unary operation. I can say input is a table R, so I can say this is unary operation. Okay, and this is the notation. Here you can see this P. This is the tuple selection condition. Okay, and what is the purpose? Purpose is filter rows based on the condition. The schema will be same as the input. So you can see, for example, if this is your table R, then tell me, if I apply this query, then what will be the output? What will be the output of this query? This is the table. So you can see on this table R, this is the tuple selection condition. A is equal to B and D greater than 5. Remember this tuple selection condition we will apply on each tuple independently. So let's apply this on the first tuple. Will it be selected or rejected? This will be selected, right? Because you can see D greater than 5 and A equal to B. So this first tuple will be selected. You can see this first tuple is selected. Next, this second tuple, this will be rejected because you can see A is not equal to B. This tuple will be rejected because D not greater than 5. This tuple will be selected. So finally, this will be your output. Very simple. You can see that the schema is not changing. So that's it. Now let me tell you one more thing about the tuple selection condition. What you can write in the tuple selection condition? What is allowed in the tuple selection condition? So let me tell you that. The tuple selection condition. So you can see sigma, this P, this is the tuple selection condition, and this is the table name R. Okay, so let's see what we can write in this P. In this P, basically we can write like this. These things we can write. Okay. Remember here we can write and or. You can write, for example, either and you can write or you can write or. Okay. So different conditions you can join with and or. Okay. Very simple. And you can see here what we can write. Here we can write, for example, attribute is equal to attribute, or you can write, for example, attribute is greater than some constant. Okay, attribute is greater than some constant. Okay, or you can write, for example, attribute is less than equal to some constant. Okay, so like this, I hope you understood. So remember, in the tuple selection condition, these type of things are allowed. Okay, very simple. So here you can write, for example, you can see attribute comparison operate, attribute comparison attribute, or you can write attribute comparison constant, attribute comparison constant, and these different conditions you can join with and or. So that's it. This is your tuple selection condition. So remember, in the tuple selection condition, we can write these and or not. These things we can use. And okay, you can see attribute operation attribute, or I can say attribute operation constant. Okay, and these symbols we can use for comparison. These symbols we can use. Okay. So very simple point. A student is asking, can we write C greater than D? Yes, no problem. See, attribute comparison attribute. C greater than D, that is also fine. Attribute comparison attribute. See, look at this. Look at this. Attribute comparison attribute. Okay, you can write these comparison operations. Okay, is this clear? Let me know. Attribute, comparison, attribute. These comparison operations you can use, or you can write attribute comparison constant. Okay, attribute comparison constant. Here again you can use these operations. Okay, you can see here. Look at this query. In this query, what is happening? See, in this query, this is happening sigma from table R. Basically, what we are doing here, you can see that A should be equal to B, and this is the symbol for and. Okay, this is the symbol for and. Okay, so this is the symbol for and this is the symbol for or, and this is the symbol for not. So you can see this and D greater than 5. Is this clear? So like this, A equal to B and D greater than 5. Okay, let's move on. So we have seen these simple points. For example, if this is your table, then what is the output of this query? You can see from the cells table, this is your cells table. You can see we are selecting tuples which satisfy this condition where bar is equal to jaws. Okay, so you can see bar should be equal to jaws. So these two tuples will be in the output. In the output, these two tuples will come, and these remaining tuples will be rejected. You can see the input and output, they have same schema. Schema is not changing. Okay, tell me the answer for this question. Let's see. Select the tuples for all employees who work in department 4 and make over 25,000 per year, or work in department 5 and make over 30,000. Then how to write the query? I want to write the query for this. So how to write? Very simple. Remember, we want to select tuples from all employees. So there is an employee table. There is an employee table. From this employee table, I want to select tuples. I want to select tuple. And what is the tuple selection condition? You can see this is the condition that either they work in department 4 and make over 25,000, means either this should happen, or this should happen. Okay, there is or here. So either, so you can see what can happen. I can say they work in department 4, means department number is equal to 4. Okay, either this should happen, department number is 4, and you can see salary is greater than 25,000, or department number is 5, and this salary, this is greater than 30,000. Okay, so this is the query. Is this clear? Very simple, you can read. So this is the employee table, this is the selection operation. You can see either this should happen or this should happen. Okay, department number 4 and salary more than 25,000, or department 5 salary more than 30,000. Okay, so very simple, like this you can write. Now let me tell you one important point, that is that selection condition, this tuple selection condition, remember that is applied on each tuple independently, individually. Is this clear? So remember, this tuple selection condition, when you apply on any tuple, at that time assume that you don't know other tuples. Is this clear? The tuple selection condition, remember, very important point, this tuple selection condition, this is applied on each tuple independently, individually. Okay, on one tuple at a time. So when you apply this on any tuple, then assume that the remaining tuples you cannot see. The remaining tuples you cannot see. Is this clear? So very simple. The tuple selection condition is applied independently to each individual tuple in the relation R. Okay. Now let's see some more things. Let's see some results. Let's see some results. Okay. If you apply this query, if you run this query, now you tell me. First of all, you tell me the schema will change or not. What will be the schema of this result? The schema is unchanged. Yes or no? Okay, I can say the schema unchanged. So the schema of input and output, that will be same. Schema will be unchanged. What about the cardinality? What about the cardinality and what about the degree? You tell me about degree, or I can say arity. You tell me about arity. Will it be same? You tell me about degree arity. Okay, what about this? Will it be same? Degree means number of attributes, right? Yes or no? Degree means number of attributes. You already know. Degree means number of attributes. So degree means number of attributes. Now you can easily see that degree of this output, degree of this output will be same as degree of R, because the schema is not changing. Okay, number of columns is not changing, so degree will be same. What about cardinality? What about cardinality? What is cardinality? That is number of tuples. Yes or no? That is number of tuples. So you tell me about cardinality, number of tuples. What relation I can write? I can say that cardinality of this result and cardinality of R. What is the comparison? Let me know. What is the comparison? The comparison is the result cardinality will be less than equal to the cardinality of R. Yes or no? Okay, less than equal to. Can it be more than? For example, is it possible you can put more than? Is it possible? No, this is not possible. Okay, because some some tuples you can remove. We are not adding any tuples. Yes or no? Some tuples we can remove. We are not adding any tuples. So very simple cardinality. So the cardinality of the result will be less than equal to cardinality of R. Okay, so these simple points we have already seen. You can see this, that cardinality of the result that is less than equal to cardinality of R. And remember, number of attributes that is unchanged. Okay, number of attributes that is same as number of attributes in R. So the degree is unchanged, the schema is unchanged, select operator is unary operator. It will apply on each tuple individually. Okay, this selection operation will apply on each tuple individually. All these points we have seen. Are you comfortable? Please tell me. Look at this query. Tell me, is this query correct or not? Look at this query. Look at this query and tell me, is this query correct or not? This query is wrong. Okay, this is a wrong query. Why? Tell me why. Because I told you the tuple selection condition is applied on each tuple one by one independently. Okay, so we cannot write like this, that every popularity in user table. Okay, because remember the tuple selection condition, this selection operation, this is applied to each tuple individually, independently. Okay, so when you apply this selection operation, when you apply this on any tuple, then assume that you cannot see the remaining tuples. Okay, so this type of query is wrong. Let's move on now. Is selection operation commutative? Tell me, is the selection operation commutative? What it means? Let me tell you what it means. It means that if I do this, for example, this is your table R. Let's assume I apply this sigma condition 1, and then on this I again apply sigma condition 2. Okay, will it be same as on this R, if I first apply condition 2, then I apply condition 1? Will they be same? Are you understanding the difference? I'm asking, is the selection operation commutative? Means this query and this query, will they be same? On the table R, first I apply condition 1, then I apply condition 2. And here, first I apply condition 2, then I apply condition 1. Will they be same? The answer is yes. The answer is yes. Okay, because see, this is very simple. Tell me what this means. You have a table R. Okay, first you want those tuples which satisfy condition C1. Okay, we want those tuples which satisfy condition C1. Then I want those tuples which satisfy condition C2. Then overall, what I am doing? Tell me. Here, overall, what is happening? Which tuples I am getting? You tell me which tuples I will get. A simple question I am asking, which tuples I will get from this table R. First you want those tuples which satisfy condition C1. So this will give me those tuples which satisfy condition C1. Then I'm getting those tuples which satisfy condition C2. So overall, which tuples I am getting? overall I am getting those tuples where C1 and C2 both conditions are satisfied. Do you agree with me? Do you agree with me? Basically, overall, I want those tuples where C1 and C2 both conditions must be satisfied. Okay, here I have those tuples which satisfy both the conditions. First, you satisfy condition C1, then you satisfy condition C2. So, overall, these two conditions, both of these two conditions you satisfy. So, now you can easily see. Okay, now can you notice they are same? This will be same as what? Here also, both the conditions you need to satisfy. Is this clear? So overall, I can say that sigma, whether you apply this C1 first, C2 first, the result will be same as whether you apply C2 then C1. Okay, basically both will be same. Is this explanation clear? Please tell me. Did you understand? And will you forget it? Will you forget it or not? Let me know. Just understand the logic. Don't buy heart. If you buy heart, you will make mistake. Just understand the logic. What is happening? So did you understand this? See, understand the first line. Because here basically we want those tuples which satisfy conditions C1 and C2. Here also the same thing. So finally I can say these two are same. Okay, is this clear? So remember, important property of selection operator. What is that? That is commutative. Important property. This is the important property, that selection operation is commutative, means sigma C1, okay, inside you have sigma C2R, that will be same as, sigma C2 sigma C1R, and both of them will be same as what? Both of them will be same as C1 and C2. Both of them will be same as sigma, okay, this C1 and C2R. So this is the property. So this is the important property. Basically, I can say this property is called commutative property. Okay, yes or no? Look at this. This is called commutative property. So selection is commutative. Selection is commutative. Understood? Very simple, right? Okay, let's move on now. Can I do the same thing if I have many sigma, sigma, sigma like this? Can I can I do the same thing? For example, if I have, let's assume I have sigma P1, okay, then inside I have sigma P2, okay, then inside I have sigma P3, okay, like this. Okay, any number of sigma I can have, yes or no? This will be same as what? You can change the order, no problem. Okay, yes or no? You can change the order, no problem. Basically, overall, this will be same as sigma. P1 also must satisfy, and P2 and P3. All of them must satisfy. All of them must satisfy. P1 and P2 and P3, all of them must satisfy. So very simple. Okay. So these are the properties you can see. Properties of selection operation. Okay. So this selection condition we will apply to each tuple. Yes or no? We will apply the selection condition to each tuple independently. Okay. This is unary operation. The degree will remain same. The schema will not change. Number of tuples in the result is less than equal to number of tuples in the input. Okay. Yes or no? Commutativity is there. So you can see condition 1, condition 2, that is same as condition 2, condition 1. Okay, yes or no? So all the results we have seen. Also, we have seen this. For example, you can see sigma C1, sigma C2, sigma Cn. That is same as sigma C1 and C2 and Cn. Okay, so all these important properties we have seen. So this is your selection operation. We have completed it. Please tell me, understood? Now we will study projection operator. We have done the complete analysis of this selection operator, all the important properties, everything. Now let's study the next operation, that is projection operator. What is this projection operator? So let me tell you the symbol. First of all, let's see the symbol. Symbol is pi. The symbol is pi. This is the symbol, and the syntax is like this. Syntax is like this, pi. Then you have some list of attributes. For example, a1, a2. These are the attributes. Okay, or maybe a1, a2, a3. So you have list of attributes and r. Okay, so let me tell you what this projection operator does. Basically, it projects attributes, or I can say basically it will project attributes, or I can say it will filter attributes. Okay, remember, it will filter attributes, it will filter columns, it will filter columns. Is this clear? It will filter columns means from the table R, basically we just want these three attributes. We are filtering the attributes. Okay, yes or no? We are filtering the attributes. This is called attribute list. This is called attribute list. Okay, is this clear? So from the table R, we only want these three attributes. So this is the simple point. Okay, so now let me tell you, for example, let's assume you have table R, and in this table R, let's assume you have these attributes A, B, C. Okay, and these are the tuples you have, for example, 1, 1, 2, 1, 1, 3. Okay, 1, 2, 1. This is your table R. Now, if I run this query, okay, if I apply this query that I want only these two attributes AB from R. From R, I want only attributes AB. Then what will be the output? Tell me. In the output, how many tuples will be there? I only want AB. How many tuples will be there? I only want AB, remember. Only these two attributes I want. So the answer will be 1, 1, 1, 2. Okay, remember duplicates will be removed. Yes or no? Remember duplicates will be removed because in the relational algebra, the table is a set of tuples. Okay, the input and output, all the tables, they have set of tuples. So means duplication is not allowed. You cannot put duplicate tuples. Very simple. So this is the idea. Okay, so tell me one thing: is the schema changing? Is the schema changing? This schema and this schema, are they different? Yes, they are different. Schema is changing. Also, the cardinality can change. Yes or no? Also, the cardinality can change. Here cardinality 3, here cardinality 2. So schema is also changing and cardinality also can change. Okay, so very simple. This is your table R. Now, what is the output of this query? This is the projection. We are projecting AC from R. We are projecting AC. Remember, we are only projecting AC. So you can see alpha 1, okay, alpha 1, beta 1, beta 2. So your answer will be this. Okay, is this clear? Very simple. So this is the projection. In the projection, what we are doing, we are filtering the attributes. So can I say projection basically that is a vertical partition? Can I say projection is vertical partition? Tell me. Can I say this projection, this is basically vertical partition? Vertical partition, because what is happening, see, very simple, that if this is your table R, then this is the table R, then remember the attributes you can divide into two categories. Yes or no? The attributes you can divide into two categories. We can divide attributes into two categories. These are the projected attributes. These are the projected attributes. Okay, yes or no? And these are the filtered out. Or I can say these are the removed. So very simple. So I can say that this projection, this is basically vertical partition of table. Simple. Okay. For example, if this is your table and I only want the name attribute. Okay. Yes or no? I want to project name attribute. This pi means project. So from the student table, I want to project only the name attribute. Then this will be the output. Okay. And remember again the same thing. This result you are assigning to S means basically this result we will call it S. We will call it S. Very simple. Okay. So this is projection. Again, this is unary or binary. Let me know. Is this unary or binary? The input is single table R. So this is unary. The input is single table R. You can see. This is the syntax. What is L? L is a list of attributes. Okay. Very simple. What is the purpose? Purpose is output the chosen columns. Very simple. Okay. If this is your input table, let's see this example. If this is your input table, and then what is the output of this query? What is the output of this query? Basically, we are projecting. Pi means project. We are projecting these two attributes. UID name. These two attributes we are projecting. So this will be your output. Simple. Okay, so we have seen this. This is the projection. This is the list of attributes. You can see this is your user table, and I want to project age. Yes or no? Pi means projection. I want to project this attribute age. Okay, so you can see duplicates will be removed, remember. So in the output, there will be only two tuples. You can see. Okay, duplicate tuples, they are removed by definition. Okay, eliminate the duplicates. If there are duplicates, eliminate the duplicates. You can see if this is your input table and I run this query, okay, then what is the output of this query? Very simple. Pi means project. I want to project these two attributes, beer, price. Beer, price, these two attributes I want to project. Then again, duplicates will be removed. Here you can see this and this. First and third tuple, they are duplicates, so duplicates will be removed. Okay, so you can see this will be the result. In the result, we will have three tuples. So that's it. We have seen this. Now, let me know some important points. Again, some results. If I apply this pi L R, what is L? This L is basically attribute list. This L, this is a attributes list. Okay, so you tell me, the schema will change or not? Let me know. The schema will change or not? What will happen to schema? Schema may change. Yes or no? Schema may change. Okay. Second, what about degree? Let me know about the degree. The degree of this result. What can you say about the degree of this result, and what can you say about the degree of R? What can you say? What is the relationship between them? The relationship between them, that is less than equal to. Yes or no? Very simple. What about the cardinality? What about the cardinality of this result? Okay, means I am asking the cardinality of this result. Can I say that will be same as cardinality of R? Can I say? No, it will be less than equal to. Okay. Don't say it will not change, because duplicates will be removed. Yes or no? Duplicates will be removed because duplicates are going to be removed. Okay. For example, consider this. If you have a table R, and in this table R, let's assume you have A, B. Okay. 1, 2, 1, 3, 1, 4, 2, 4. Now look at this. Then tell me, what will be the cardinality of pi A R? Just tell me the cardinality of pi A R. Let me know. What the cardinality of pi A R? That will be 2. Yes or no? Okay. Because when you project the attribute A, then only two tuples will be there. The duplicates will be removed. Yes or no? The cardinality of R is actually 4. Okay. And what the cardinality of pi B R? That will be 3. Yes or no? Okay. Is this clear? So remember, the cardinality of this result, this projection result, that will be less than equal to cardinality of R. Is this understood? Please tell me. Now tell me the answer for this question. To make sure that cardinality of projected relation is necessarily same as the input relation for every instance, then what can you say about the attribute list? Please tell me. I want to make sure that cardinality does not change. Cardinality of projection does not change. For every instance, the cardinality of the projection does not change. Okay, then what can you say about the attribute list? Very simple. If the cardinality of projection should not change, then it means in the attribute list we must not have duplicates. Yes or no? Do you agree? If the cardinality of projection should not change, then it means attribute list must not have duplicates. So I can say this must be a super key. Okay, yes or no? So this must be a super key. If the attribute list is super key, then you can see the cardinality of input will be same as the cardinality of the output. Okay, is this clear? Let me know. Understood? So very simple point. Remember this, you have relation R, okay, and consider this query. Consider this query. Now you can see if L is super key, if L is super key, then what will happen? Then this will definitely happen that cardinality of this result will be same as cardinality of R. Is this clear? If L is super key. Okay, so very simple. The same thing you can read here from the Navate book. The same thing that I told you that is written here, you can read it. Is projection operation commutative? Please tell me. Is the projection operation that is commutative? Means what I want to ask? I want to ask pi. First, let's assume I apply some attribute list on R, and then I apply some other attribute list. Okay. Can I say this will be same? Can I say this will be same if I do this L1 and here L2? Think about it and tell me, will they be same? Will they be same? The answer is no. The answer is no. Okay. Because see, very simple point. Let me give you one example. Consider this R. In this R, let's assume these are the attributes A, B, C, D. Okay. Now just consider this pi on this R. Let's assume first I am projecting ABC. Then I am projecting AB. Okay. Is this clear? Now you tell me. So this is your L1 and this is your L2. So tell me, will it be same if I write like this? If I write like this, here I write L1 and here I write L2. Are they same? Let me know. Are they same? This is not even valid. Yes or no? This is not even valid. Invalid. Yes or no? This is invalid. So remember that this projection operation is not commutative. Is this clear? Did you understand? Projection operation is not commutative. You cannot commute. You cannot commute the projection operation. You can see this is invalid. First you are projecting AB, then you are projecting ABC. That is invalid. Why this is invalid? First you are projecting AB. Now here you only have AB attributes. Consider this. Here you only have AB attribute. From AB attribute, can you project ABC? From AB, can you project ABC? No. Okay, so that is the reason this is invalid. I hope you understood. Is this clear? So this projection is not commutative. Okay. Now let me tell you a property of projection operator. And this is important property. So it is like this. Just think about it and tell me. Let's assume you have this A, B, C, D. This is your table. And let's assume that pi from this R, first I'm projecting ABC. Okay. And then I'm projecting AB. Okay. Can I directly project AB? Will it be same as if I directly project AB? This is my question. If I directly project AB, will this be same? Think about it. This is your, let's call it, this is your L1. Let's call it L2. Okay, tell me, think about it and tell me, can I directly project AB? The answer is yes. The answer is yes. Okay, just think about it. The answer is yes. Why? See, first I'm projecting ABC. Okay, here I will get ABC. Here I will get ABC. Then I will get AB. Overall, ultimately, what you are getting? Tell me, finally, what you are getting? Finally, we are getting all the tuples of AB. Finally, we are getting all the tuples of AB. All the tuples of AB we are getting or not? Here we are getting all the tuples of AB. So the same thing I will get here, all the tuples of AB. And remember, duplicates are not there. So you don't have to worry about duplicates because duplicates will be removed. Okay. So you can see here I am getting attribute AB. Here also I am getting attribute AB. So this is the property of projection. What is the property? Let me tell you. The property is like this. If you apply like this, pi, okay, first let's assume you have pi L1 on R, and then let's assume you apply pi L2. First, you tell me if this is valid query, then what should be relation between L2 L1? A very simple question I am asking. If this is valid query, then what is relation between L1 L2? L2 is subset of L1, right? Yes or no? Okay, this is a simple thing. You can see. Okay, I'm asking if this is valid, to be valid, to be valid, okay, what will happen? The L2 must be subset of L1. Okay, if this should be valid. Is this clear? Is this understood? Because this L2 must be subset of L1. Very simple point. Okay. Now you tell me that, so here I can say this, if L2 is subset of L1, then can I say that I can directly project L2? Yes or no? I can directly project L2. Okay, but this would happen that if L2 is a subset of L1, then I can directly project L2. Is this clear? Is this understood? Please tell me. Let me know. Simple, right? So let's move on now. So you can see this is the project operation, that is unary operation. Okay, the degree will be, the degree can change. Yes or no? I can say the degree will be same as the number of attributes in the attribute list. The degree of the result will be same as number of attributes in the attribute list. Very simple. Okay, number of tuples can change because of duplicate elimination. Commutativity does not hold for project operation. Also, you can see if L1 is subset of L2, if L1 is a subset of L2, then I can directly project L1. All these properties, did you understand? Let me know. Now let's see properties of selection and projection operation. First, tell me, this property we have already seen. Selection operation is commutative. We have already seen selection operation that is commutative. Yes or no? This point we have already seen that selection operation is commutative. This is same as this, and this is same as C1 and C2 are. So selection operation is commutative. This we have already seen. Here you can easily see that, okay, you can see sigma p sigma q r, that is same as sigma p and q r. Okay, so selection is actually commutative. Okay, whether you have sigma p sigma q or you have sigma q sigma p, both are same. Okay, so this we have seen. We have also seen this. If you have many in a sequence, if you have many selection like condition 1, condition 2, condition n, then overall you can say condition and condition 2 and condition n. Okay, so these simple points we have already seen. What about projection operation? That is not commutative. Yes or no? Projection operation is not commutative. This point also we have seen. Okay, so if you have, let's assume pi L1, pi L2 R, then this is not same as pi L2, pi L1 R. Okay, simple. So here you can see. And this point we have seen that if A is subset of B, then can I say this property will hold? If A is subset of B, then can I say this property will hold? Yes. Yes or no? If A is subset of B, then I can directly project A. I can directly project A. So you can see if this list 1, this is subset of list 2, then I can directly project list 1. So these properties we have already seen. Now let's move on. Can we commute selection and projection operation? This is my question. Next question. Can we commute selection and projection? What this means? Basically, I want to ask you that, let's assume you have this selection first. First you are applying selection, then you are applying projection. Can I say this will be same as, can I say this will be same as first I apply projection and then I apply selection? Please tell me, will it be same as this? Will they be same? Can I say they will be same? Can I commute selection and projection? This is my question. Can I commute them? Let me explain with help of one example. Consider this table. Okay. In this table, I am giving you. So let's consider first I am doing this selection A equal to alpha from R. Okay. And then I'm projecting, I'm projecting the attribute C. I'm projecting the attribute C. Okay. Now tell me what will be the result of this query and what will be the result of this query. First, I project attribute C and then I apply condition A equal to alpha. Now tell me what will be the result of this query and what will be the result of this query. Please tell me what is the result of this query. The result of this query that will be, first you filter tuples where A is alpha. So these two tuples will be selected. Yes or no? These two tuples will be selected. Then I want to project attribute C. So output will be basically, output will be like this. Output will be 1 5. What about this query? What I'm doing? I'm commuting them. Yes or no? I'm swapping them. So if I swap them, now tell me, this is actually invalid. Yes or no? This is invalid because here you have attribute A. Sorry, here you have attribute C. Can you apply this condition? Yes or no? Very simple. So remember, this will be invalid query. So can I commute? Can I commute selection and projection? Tell me, can I commute selection and projection? Let me know. The answer is no. Okay, can I commute selection and projection? The answer is what? The answer is no. I cannot commute selection and projection. Is this clear? Please tell me. You can see this example, you can see here this query is fine. This query is fine, but if I commute them, if I swap them, if I swap, then you can see this query is invalid because here you will have attribute C. Can I apply this condition on attribute C? This condition can I apply on attribute C? The answer is no. So you can see this is invalid. Okay, so I can say that you cannot swap. I can say you cannot commute selection and projection. But now consider this. Now consider this situation. I'm applying the condition on, let's assume A. Okay, I apply the condition on A. Now I project, let's assume A comma B. Okay, is this clear? I project A comma B. Now let me swap. Now let me swap. So first I project A comma B and then I select A equal to alpha. Okay, now you tell me, will they give the same result? Did you notice what I'm doing? I'm commuting select comma project. Okay, you can see I'm commuting select comma project. So you tell me, now will they give the same result? Yes, now they will give the same result. Okay, first here you can see those tuples where A is alpha. So here these two tuples have alpha. Okay, these two tuples, they have alpha. Then projecting AB. Okay, so here the output will be like this. Here the output will be alpha 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 beta. Okay, yes or no? And what about this? First I project AB. First I project AB. First I project this. I project AB. Then where A is alpha. Then where A is alpha. Okay, first I project AB and then where A is alpha. So finally I can say alpha 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 beta. Are they same? Yes, they are same. So tell me why they are becoming same. Did you notice? You can see in this example, I can commute. Okay, but in the previous example, I cannot commute. Like in this example, I cannot commute. Did you understand? Did you observe the difference between this example? Here I cannot commute these two. Projection comma selection I cannot commute. Let me tell you the reason. The reason is like this, because this selection condition is not on this attribute list. Yes or no? Did you notice? This attribute list is different, and this selection condition is on a different attribute. This selection condition is on a different attribute. This is on attribute A, and this attribute list, this does not contain A. Okay. And now notice here. This attribute list contains AB, and the selection is on attribute A. So in this situation, I can swap, I can commute. Okay, so let me tell you that this is the question. Can we commute selection comma projection? The answer is no. Okay, remember the answer is no. The answer is no. It means if I give you this equation, pi L sigma C R, will it be same as sigma C pi L R? Will they be same? The answer will be no. Okay, the answer will be no. But now notice, if I give this condition, okay, if C uses attributes of L, if C uses attributes of L, remember, if C only uses attributes of L, I can say, if C uses of attributes of L only, then tell me, okay, if C uses attributes of L only, now remember, now they will be same. For example, now if I write this pi L sigma C R, now this will be same as sigma C pi L R. Okay, is this clear? Let me know, did you understand? Simple point. Okay, so this is a simple point, remember, and this is important. In the GATE exam, they can ask you this. This is simple point, that if this is C, if this condition C, if C uses, if C only uses attributes of list L, okay, is this clear? Then remember, we can commute. Then in this situation, whether you have this pi L R, this will be same as pi L sigma C R. Okay. The example we have already seen, but let me give you one more example. For example, what about this? What do you think? Can I commute? Just look at this condition, and this is the list. Now tell me, can we commute? Do you think we can commute? This is condition C. This is condition C. And this is list L. What do you think? Can we commute? Can we commute? Or I can say swap. Can we commute pi comma sigma? The answer will be yes. Let's check it. Okay, let's check the result of this, and let's check the result of this. You tell me, are they giving the same result? Let's check the result of this one. Are they giving the same result? See what this result, what this query will give, what result this query will give. First, you are selecting tuples where rating is greater than 8 from S2. This is your S2. From S2, we are selecting tuples where rating is greater than 8. Where rating greater than 8. So this will be gone, this will be gone. These two tuples will be gone. Remember, yes or no? Because here rating is not greater than 8. So these two tuples will be selected. And then we are projecting as name rating. So the output will be as name rating. The output will be like this. Okay, the output will be like this. The output will be, you can see as name and rating. So that will be yuppie. Rating is 9. Rusty. Rating is 10. Okay, what about this query? What the output of this query? First we project as name rating. First we project as name rating. First we project this. Then we select tuples where rating is greater than 8. Then we select this tuple and this tuple. Did you notice we are getting the same output? This query is also giving the same output. As name rating. Yes or no? Is this clear? Please tell me. Did you understand? Let me know. Is this point clear? So they are giving the same output. I hope this point is clear to everyone. Let me know. Okay. So finally, I can say this is the note. The note is very simple that if if C if C uses attributes of L, then we can commute. Yes or no? If C uses attributes of L only, then we can commute. Okay, then what we can do? Then we can commute. For example, in this situation, this query will be same as this query. Okay, understood? Let me know. Is this clear to everyone? Please tell me. So very simple point. Here you can see if the condition uses attributes of A, if this condition P uses attributes of only A, then we can commute. Then we can commute. Okay. Yes or no? Is this clear? Simple. Then you can see we can commute. Okay, let's move on now. So these are the properties of selection and projection. Let's see these properties. Look at these properties and tell me, did you understand all of them? These are important. In the GATE exam, they can ask you many questions based on these properties. For example, did you understand this? That sigma C1, sigma C2R, that is same as sigma C1 and C2R. Commutativity of selection. Sigma C1, sigma C2 is same as sigma C2, sigma C1. Yes or no? And we have already seen if this attribute list is subset of this attribute list, then we can directly project this attribute list. Yes or no? So the third property also we have seen. And the fourth property also we have seen. If this attribute list includes the attributes of C, then we can commute sigma comma pi. So all these properties we have seen. I hope you understood. Is this clear? Let me know. Let's solve this GATE 1998 question. This is a very beautiful question. Which of the following query transformations, means replacing the LHS expression by RHS expression, is incorrect? Which of the following query transformation is incorrect? You are replacing LHS with RHS, then which of the following transformation is incorrect? R1 and R2, these are relations. C1, C2 are selection conditions. A1, A2 are attributes of R1. Okay. Now the question is asking which of these transformation are correct. Okay. So let's see the first one. The first one is saying sigma C1, sigma C2. Can I replace this with this? Yes, we can do that. Actually, LHS and RHS are actually equivalent. We already know this. Okay, let's look at option A. What option A is saying? Option A is saying that if you have this query, can I replace this query with this query? Can I do this? Can I replace? Yes, we can replace. Okay, very simple. You already know. Actually, this LHS is actually equivalent to RHS. Okay, so you can replace this also, you can replace this also. Both are fine. Okay, you can replace in this direction also, you can replace in this direction also. Both are fine. Because actually LHS and RHS, they are actually equivalent. We have already seen that this LHS, this is same as sigma C1 and C2 of R. Similarly here, this is same as sigma C1 and C2 of R. So you can see they are actually equivalent. Means if you have this query, I can replace with this query. And if you have this query, I can replace with this query. Okay, both are fine. Is this clear? So I can say this transformation is correct. This is actually correct transformation. What about option B? Option B is saying sigma C1 pi A1. This query I can replace with this query. Okay, let's see option B. Option B is saying sigma C1 pi A1 R. I can replace this query with pi A1 sigma C1 R. Okay, so tell me, can I do this replacement? This replacement can I do? Okay, before anything, you tell me, are they equivalent? I'm asking, are they equivalent? This LHS and RHS, are they equivalent? Can I say they are equivalent? LHS and RHS, are they equivalent? Please tell me. Are they equivalent? They are definitely not equivalent. Okay, they are definitely not equivalent. The answer is no. They are not equivalent, right? We have already seen that they are not equivalent. Okay. Now you tell me they are not equivalent, but the question is not asking about the equivalence. Please understand. The question is asking about the transformation. The question is saying that if LHS is valid query, then can I replace this with RHS? In your system, let's assume you have this query in your system. Then can I replace that query with this query? So one assumption automatically you will make that LHS query are valid. Do you agree with me? Do you agree with me? See, very simple point. The question is asking about the transformation. The question is saying that this query can I replace with this query? So it means this is already a valid query. Now we are replacing this query with this query. Yes or no? Is this clear? So this is a beautiful question because the question is not asking about the equivalence. See, here LHS and RHS, they are not equivalent. But the question is asking, if this is a valid query, can I replace this with this query? Is this question clear to everyone? In your system, let's assume you have this query already. This query is already there. Okay, now to make your system efficient, maybe, okay, maybe efficient or inefficient, doesn't matter. But to basically, this query can I replace with this query? And will I get the same result? Will I get the equivalent result? Did you understand the question? Let me know. So remember, in this option B, this is your option B. Can I replace this with this? In this option B, actually LHS and RHS, actually they are not equivalent. But the question is not asking about equivalence. The question is saying, can I replace this with this? So you tell me, if this is already valid, then what it means? Just think about it. If this is already valid, if this is already valid, if this is valid, if this LHS is already valid, then what it means? It simply means C1 is using attributes of A1. Do you agree with me? If this query is already valid query in your system, you have this query. So this is a valid query in your system. Now we want to check, can we replace this query with this query? So first to tell me, if this query is already valid query, then it automatically means what? It means this C1 is using attributes of A1. Yes or no? Then I can say, then C1 uses attributes of A1 only. Okay. Now in this situation, when C1 is using attributes of A1 only, then definitely we can replace this query with this query we have already seen in our lecture. Okay. Previously, we have already seen this. Agree with me? Please tell me. Is this question clear? So option B, this transformation is correct. Remember this transformation, this is correct. Okay, because if this is already valid, it simply means that C1 is using attributes of A1. And in this situation, definitely I can say, remember, in this situation, this query will give you the same result. Yes or no? In this situation, this query, they are same. So very simple. This transformation is definitely correct. Okay, let's see the remaining. Let's see option C. Option C is sigma C1 R1 union R2. Okay. And here sigma C1 R1 union sigma C1 R2. These are actually equivalent. This LHS and this RHS, they are actually equivalent. Again, here also in option C, let me tell you, in option C, they are actually equivalent. See, option C is saying that you are doing sigma C1. You are applying some condition on tuples of R1 union R2. What is R1 union R2? This is the union of union of both the tables, yes or no? So in this you will have all the tuples of R1, also all the tuples of R2. Okay, you just tell me one thing. Can I say this is equivalent to this? Think about it and tell me. Are they same? Are they same? Let me know. See, just think about it. If any tuple is here, can I guarantee that tuple will be here? Okay, see, very simple point. Sorry, this is C1. This is a C1. Okay, because you can see here, you can see sigma C1, sigma C1, sigma C1. Okay, so tell me here, in this option C, you tell me if any tuple, okay, so I can say here this is C1. Very simple question I'm asking. Let's assume there is a tuple here. Can I guarantee that tuple will be here also? Okay, let's assume there is a tuple here. This tuple T, this tuple T is here. It automatically means what? In this result, you have tuple T. It means what? This tuple is either in R1 or R2 and it satisfies condition C1. Can I say this T1 satisfies this tuple T satisfies C1? Do you agree? In this result, you have tuple T. What it means? It means T satisfies C1, T satisfies this condition C1, and T either belongs to R1, T either belongs to R1 or T belongs to R2. Agree? Either T1, T either T belongs to R1 or T belongs to R2. Now you tell me, will this T be in this result? Will this T be in this result? Yes. Because remember, if T belongs to R1 and already T satisfies condition C, yes or no? Already T satisfies condition C1. So remember, there is no problem. This tuple will satisfy condition C1. Now, if this T belongs to R1, then T will belong here. Yes or no? Then T will come here. And if T belongs to R2, if T belongs to R2, then T will be here. Overall, I can say in the union, definitely T will be there. Do you agree? I can say whatever you do, T will definitely be there here. Okay, T is present. Is this clear? So very simple. If T is present in this, then T will be present in this. Do you agree with me? Let me know, did you understand? Very simple point. See, look at this query. And I'm telling you that in this result, if you have tuple T, then that tuple will also be there in this result. Now, very simple. In this result, if I have tuple T, then it means tuple T satisfies condition C1. Okay, T satisfies condition C1 and this T must be either in R1 or in R2. Either T is in R1 or T is in R2. Okay, now you can see, remember T satisfies C1. So there is no problem. This tuple will satisfy the condition C1. Now, whether you take this case or whether you take this case, in both the cases, what will happen? In both the cases, I can say here we are taking union. So in whatever case you take, I can say T will belong to this. Okay, is this clear? Please tell me. So I can say that if tuple belongs here, then definitely it will belong here. Now what we need to prove? Now we need to prove if T belongs here, will it belong here? If T belongs here, if tuple T is here, if tuple T is present here, what it means? This tuple T, this is present here. What it means? It means either this tuple is coming from here or this tuple is coming from here. Do you agree with me? Do you agree with me? If T is present in this result, if tuple T is present in this result and there is union here, if tuple T is present in this result, then I can say either T is coming from here, either T is coming from here, or or T is coming from here. Agree? Let me know. Agree or not? Okay. Now you tell me, whatever case I take, if I take this case, assume I take this case, means T is coming from here, then can I guarantee T will be in the output of this query? Assume T is here. In this result, T is there. Okay, just assume that in this result you have T. In this result, you have T. What it means? It means T belongs to R1 and T satisfies C1. Yes or no? It means T satisfies C1 and T belongs to R1. Okay. So if T belongs to R1, then T will belong to R1 union R2. Agree? If T belongs to R1, then T will belong to R1 union R2. And already T satisfies condition C1. So this T will satisfy condition C1. So T will be in this result. Yes or no? Similarly, you can do the other. Similarly, you can say if T is coming from here, if tuple T is coming from here, it means T belongs to R2 and T satisfies condition C1. So if T belongs to R2, then T will belong here and T satisfies C1. T satisfies C1. So T will come here. So finally, the result is if T is present in the RHS, then T will be present here. So finally, I can say LHS, RHS, they are actually equivalent. Is this clear? Please tell me in this option C, LHS, RHS, they are actually equivalent. Condition C1, R1 union R2. This is actually equivalent to condition C1, R1 union condition C1, R2. The proof, did you understand? Please tell me. This was a beautiful proof. I hope you understood this. This was not complicated. This was an easy proof that this query, they are actually equivalent. If this query has any tuple T, then this query will also have tuple T. And if this query has tuple T, then this query will also have tuple T. This is what we have proven. So they will have same result. Okay, they are actually equivalent. Is this clear? So you can do this transformation, no problem. You can do this transformation, no problem. Both the transformation you can do. This is your option C analysis. Now let's see option D analysis. Let's see what is option D. Option D is saying, can I replace this query with this query? Pi A1 sigma C1. Sigma C1 pi A1. Okay, so you can see option D is saying, can I replace this query pi A1 sigma C1 R1? Can I replace this query with sigma C1 pi A1 R1? Let me know. Is this transformation correct? Is this transformation correct? See, first you tell me, can I say they are equivalent query? You just tell me this point. Can I say they are equivalent? Are they equivalent? No, they are not equivalent. But the question is not asking equivalence. Yes or no? Question is not asking equivalence. Question is saying, if this is valid query, then can I replace with this query? Okay, let's assume in your system you have this query. Now, can I replace this query with this query? So, already assume this is a valid query. Can I replace this with this query? Tell me. Again, this transformation is also wrong. Okay, this transformation is also wrong. Let me give you one condition. See, here you tell me, look at this. Assume this is a valid query. This is a valid query. Okay. So assume this is a valid query. If this is a valid query, can I say C1 will use attributes of A1 only? Tell me. Assume this is a valid query. Can I say C1 will use attributes of A1 only? No, not necessary. For example, for example, let's assume your table is R. Let's assume your table is R1 ABC, ABCD. Okay, let's assume. Now assume that this condition C1 is like this, that A is equal to 0. Okay, let's assume this is your condition sigma. This is your condition C1. This is your condition C1. And let's assume I'm projecting the attributes BD. Now you tell me, can I replace this? Can I replace this with sigma A equal to 0 pi B comma D R1? Let me know. Can I do this? No, this is not even valid. This is invalid. Think about it. This is invalid. Why this is invalid? Why this is invalid? Because remember, here I have attributes B comma D. I only have attributes B comma D and I'm using the condition on A. Here I have attribute BD and I'm using condition on A. So this is actually invalid. So this transformation is wrong. Is this clear? This option D transformation is wrong. So finally, I can say this is wrong. So this is actually beautiful question. I hope you understood this. Let me know. Is this question clear to everyone? Please tell me. I have done the complete analysis of each option. I have given you the proof of this option that here LHS, RHS, they are actually equivalent. So you can do transformation from LHS to RHS, or you can do transformation from RHS to LHS. Both are fine. Okay. Or we have also seen that this is also correct transformation. So this is the complete analysis of this question. This is a beautiful question, and this type of question they can ask you in the GATE exam. Okay, what is one possible variation? Anyone want to tell me what is one possible variation? Let's assume they ask you which transformation is correct. This is a variation. Let's assume they ask which transformation is correct. Okay, and let's assume in the question this condition is given that C1 uses attributes of C1 uses attributes of A1. Let's assume this is given that C1, this condition C1, selection condition C1 uses attributes of A1. Let's assume this is given. Now tell me which transformation is correct. This is a variation. Now which transformation is correct? Now all the transformations are actually correct. Okay, all are correct. So for this question, answer will be A, B, C, D. Okay, understood? So now let's move on. Now let's see set operations. Let's quickly see all the set operations. Tell me why we can apply set operations on the relations? Because every relation is a set. Yes or no? Every relation is called a table. This is basically a set. This is a set of tuples. Okay, so that is the reason we can apply set operations. Because it is a set of tuples, so set operations can be applied. Can be applied. Okay, we can apply set operations. Which set operations we need to see? Okay, so let me tell you the set operations that we need to study. We will study the set operations union, set difference, intersection, cross product. Okay, so these set operations we will study. Okay, and which of them is basic and which of them is not basic? I told you this is not basic, this is derived. Okay, this is derived, and the remaining are basic. Okay, and the remaining, these are actually basic. Is this clear? This one, and this one. These are actually basic operations. Okay, is this clear? Now let's see. What is union? You already know. Okay, so let me quickly tell you the definition of union, the definition of all set operations. Okay, for example, what is if I have what is R union S? What is that? That will be basically all the elements which belong to R or S. Okay, all the elements, you take all the elements of R, you take all the elements of S. Okay, so all the elements you take which belong to R or which belong to S. This is the definition of union. Okay, next, what is the definition of intersection? Intersection means common elements. You take those elements which belong to R also and which belongs to S also. Okay, is this clear? Next is set difference. Next is set difference. So here you take those elements which belong to R but do not belong to S. Which do not belong to S. Okay, which belong to R but do not belong to S. This is set difference. And what is cross product? Cross product means you combine every element of R with every element of S. Okay, means if this is element of R, okay, and this is element of S, then you combine this element of R with element of S. Okay, is this clear? So we combine every element of R with every element of S. So these are the definitions of set operations. Now you can see in the union what we do, we take all the elements of R comma S, take all the elements of R, take all the elements of S. So you can see, take all these elements which belong to R or S. So you can see if this is your table R, this is your table S, then what will be union? So very simple. take all the tuples of R, take all the tuples of S. Finally, this will be your output. Okay, is this clear? This is R union S. Remember, duplicates are removed. So very simple. You have to remove the duplicates. Next, what is R minus S? This is set difference. Means those elements which belong to R but do not belong to S. Okay, so basically those elements which belong to R but do not belong to S. So these elements are R minus S. Okay, for example, this is your table R, this is your table S. What is R minus S? R minus S means those elements which belong to R but not belong to S. You can see this belongs to R but does not belong to S. You can see this belongs to R but this also belongs to S. You can see this belongs to R but does not belong to S. So I can say the output will be these two. Okay, very simple. R minus S means those tuples, these two tuples, they belong to R, but they do not belong to S. So I can say this is in the output. Next is intersection. Intersection means common elements. You can see these are the common elements. They belong to R and they belong to S. So these are the common tuples. So you can see if I do R intersection S, then what will be the output? Tell me. If I do R intersection S, let me know. R intersection S means just take the common tuples, those tuples which belong to R and belong to S. So I can say only this tuple belong to both of them. Okay, the answer will be alpha 2. This belongs to both of them. So one tuple in the output. Very simple. Okay, so let's move on. Now, what is cross product? So let me tell you about cross product, or I can say Cartesian product. You can call it Cartesian product, or you can call it cross product. Okay, the symbol, this is the symbol cross, this is the symbol. Okay, so remember, if you have R cross S, this simply means every tuple of R combines with every tuple of S. Okay, very simple. I can say combine every tuple of R with every tuple of S. Combine every tuple of R with every tuple of S. Simple. Yes or no? Okay, combine every tuple of R with every tuple of S. This is the point. Okay, so here you can see, for example, this is your table R, this is your table S. Here you have two attributes, here you have three attributes. So in the R cross S, what we will do? There will be five attributes in the R cross S. Okay, basically combine every tuple of R with every tuple of S. For example, this tuple we will combine with everyone. Similarly, this tuple we will combine with everyone. So finally, total 8 tuples will be there. Okay, because you can see 2 multiplied by 4. Okay, because this tuple we will combine with everyone, this tuple we will combine with everyone. So this is the result of R cross S. Okay, is this clear? Simple, right? Okay, so very easily you can see. And remember, in this R cross S, you will have all the attributes here followed by all the attributes here. So there will be 5 attributes here. Simple. Now let's move on. Now let me tell you one thing, that is, if you want to apply union intersection set difference, if you want to apply these operations, then relation must be union compatible. If you want to apply union intersection set difference, these three operations, if you want to apply, then relations must be union compatible. Now, what is union compatible? Let's see. Union compatible relations. So if I give you a relation R, and let's assume these are the attributes A1, A2, and so on, AN, and you have another relation S, and these are the attributes B1, B2, and so on, BM. Okay. Now, when can I say R comma S are union compatible? When can I say that they are union compatible? Union compatible means you can do their union, you can do their intersection, you can do their set difference. So when can I say they are union compatible? They are union compatible if and only if, see, this is the condition that number of attributes must be same. First of all, number of attributes must be same. This is the first condition, that number of attributes means n should be equal to m, and what should happen? The corresponding domains must be same. The corresponding domains must be same. Domain of A1 should be same as domain of B1. Domain of A2 same as domain of B2. Domain of AN should be same as domain of BN. Okay, is this clear? So very simple point, that domain of AI should be same as domain of BI. Should be same as domain of BI. Okay, for all I. For all I. Is this clear? The names can be different. Remember, here the names can be different, but domains must be same. Okay, so this is the definition of union compatible. These two tables R, S, they will be union compatible if number of attributes must be same. Here an attribute, here also an attribute, and domain corresponding domains must be same. Domain of A1 should be same as domain of B1. Domain of A2 should be same as domain of B2. So you can see domain of AI should be same as domain of BI for all I. Okay, so very simple. This is the definition of union compatibility. And remember, union compatibility we apply only for union, union intersection and set difference. For cross product, do we need union compatibility? For cross product, we don't need union compatibility. Okay, so very simple. These points we have seen. Now let's see this example. First of all, you tell me, are they union compatible? These two tables, are they union compatible? Can I do their union? Very simple. You can see checking account, saving account. This is checking account, this is saving account. So you can see, are they union compatible? Can I do their union? Can I do their union? Yes, they are union compatible. Yes, because see, here also three attributes, here also three attributes. You can see domain of customer number and this number, sorry, domain of checking account number and saving account number, they are same. Yes or no? Domain is same. Here domain is same, here domain is same, here domain is same. The names can be different. Here checking account number, here saving account number, the names can be different. But the domain is same, right? Domain is same, domain is same, domain is same. Here domain is integer, here domain is character string, here domain is some real number. Yes or no? Did you understand? So they are union compatible. The names can be different. Union compatible means number of attributes must be same, three attributes. Okay. Next, corresponding domains must be same. Here domain is integer, here domain is character string, here domain is real number. So can I do their union? Please tell me, can I do their union? Yes, we can do their union. Okay. And one more thing, let me tell you that when you do union, R union S, first of all, they must be union compatible. Okay, they must be union compatible. Now, if you do R union S, then remember the resulting schema will be same as R. Okay, the result schema will be same as schema of R. The result schema will be same as schema of LHS basically. Schema of LHS. That means R. Okay, is this clear? The same thing you can do for R intersection S and R minus S. Okay, the schema will be same as R. So I can say same for R intersection S and R minus S. Okay, is this clear? So you can see here, if I do union of checking account, union saving account, then schema will be checking account. Can you notice? Can you notice schema is this LHS? So the schema of this LHS will be used. You can see schema of LHS we are using, and then we are doing the union. Take all the tuples from here, take all the tuples from here. This will be your output. Okay, so in this example, you can see everything. Now, let's move on. Now, let's see this. Tell me, can I do their intersection? First of all, you tell me, can I do their intersection? Checking account, saving account. This is a checking account and this is a saving account. Can I do their intersection? Yes, I can do, because they are union compatible. Here also three attribute, here also three attribute, and you can see corresponding domains are same. Okay, corresponding domains, they are same. So I can do their intersection. Tell me, what is the answer of this query? Intersection means you take the common tuples. You take those tuples which belong here also and here also. Is there any common tuple? Is there any tuple which is common? No, there is no tuple common. So empty result. Yes or no? You can see the result will be empty. Okay. So there is no tuple in the output. Very simple. Okay. Now tell me, if I do projection of C owner and here I do projection of S owner, first of all, you tell me, can I do their intersection? Here I am projecting C owner and here I am projecting S owner. Can I do their intersection? Yes, they will be compatible because here I will have C owner, here I will have S owner. So they will be compatible. They will be compatible because they have same domain. Now you tell me, what will be the result? This is C owner, this is S owner. I am doing their intersection. So take the common tuples. So one tuple will be in the output, that is J Smith. Okay, you can see one tuple in the output, that is J Smith. And tell me, the schema will be used for what? Tell me, the schema of which table will be used? The schema of LHS will be used. Yes or no? Schema of LHS will be used. So you can notice this C owner is used. Here you can easily see C owner is used. Okay, let's move on. You can see similarly difference. Okay, C owner minus S owner. So tell me what will be the output? C owner minus S owner. Basically, those tuples which belong here but do not belong here. So you can see these tuples will be in the output. And did you notice the schema of LHS we are using? You can see the schema of LHS we are using. The C owner we are using schema of LHS. Okay. So we have seen all these simple points. I hope you understood everything we have seen that is written in these slides. Every point we have seen. Okay. Yeah. Let's see this question. This is a good question. So let's see this. I want list of names of all people in the department. Okay. I want names of all people in the department, means all these people I want in the output. So tell me, can I write this query that first I take the union of student and professor? Okay. First I to take their union and then I project name. Then I project name. Is this query correct? Please tell me. Did you understand? I want list of, I want names of all people in the department. I want names of all people in the department. I want these names, these names. I want all these names I want. Then can I do this? First I do their union, then I project name. No, I cannot do that. No, I cannot do that. This is invalid. Okay, why this is invalid? Tell me why this is invalid. This is invalid. I cannot do that because student comma professor, they are not compatible. So I cannot do union. They are not compatible, right? Yes or no? You can see they are not union compatible. Not union compatible. Because they are not union compatible, so I cannot do their union. So these are invalid queries. So what is the solution then? Anyone want to give me solution? I want all the names. Then what is the solution? Yes, solution is very simple. Okay, you project names and then you do union. Yes or no? You project these names, you project these names, and then you do their union. Correct? So this will be the answer. Project names from student table, project names from professor table, then you do their union. So this is what you can do. Okay. Now, I told you intersection is not a basic operation. What it means? It means this is a derived operation. It means this is a derived operation. So can you derive it from union comma difference? Can we derive intersection from union comma difference? And this is actually very simple. Let's look at this. See, very simple. Let's assume this is your table R, this is your table S. Okay. Then you can easily see this R intersection S. Can I write like this? That I want this R intersection S. Remember, this is your R intersection S. So how can I write R intersection S? Very simple. Can I do this? That from R, if I remove S my C. From R, I remove R minus S. If I do this, then what I will get? Just think about it. From R, if I remove R minus S, see, this is your R minus S. This white is your R minus S. From R, if I remove this white, will I get this R intersection S? Tell me. From R, if I remove this white, then will I get R intersection S? Yes. Okay, so very simple. Like this, you can write intersection in terms of difference. Okay, there are many more ways. Let me tell you, for example, let me tell you another way. Okay, another way, let me tell you. R, this is S. I want intersection. This is R intersection S. This is what I want. Okay, so notice what I can do. From the union, what I have to remove? Just think about it. R intersection S. This is same as from the union. Okay, let's assume I take the union first. From the union, what are the things I need to remove? Tell me. From the union, I need to remove this. Yes or no? From the union, I will remove this. This is R minus S. And this is S minus R. Okay, so from the union, I will remove R minus S. Okay, from the union, I will remove R minus S. Then again, I will remove S minus R. Okay, is this clear? From the union, I will remove R minus S. Then I will again remove S minus R. Okay, so like this also you can write. There are many more ways. Okay, let me tell you, there are many more ways. So for example, this is R, this is S. You can see this is R intersection S. Okay, what I can do, again, very simple. You know this is R minus S. And you know this is S minus R. Okay, so what I can do, this R intersection S, I can do like this. From the union, from union, what I do, I remove the union of these two. Yes or no? From the complete union, from this complete union, I remove union of these two. I remove R minus S union S minus R. Okay. So like this, there are many ways you can write. Is this clear? There is one more way. What is that? For example, I can say R intersection S, that is same as from S I remove S minus R. Okay, all of them are correct. From R I remove R minus S. Okay, R intersection S. From R union S, I remove their union. Okay, so like this, there are many ways. R intersection S, that is same as from R union S, from this R union S, first you remove R minus S. Okay, first you remove R minus S, then you remove S minus R. Okay, so you can see there are so many ways. Yes or no? One, two, three, four. There are many ways to write intersection. So very simple. Let's move on. Now let's see some details about cross product also. Okay, so let's revisit the cross product. You already understand what is cross product, but just tell me, if you have this table R, and let's assume that there are total A1, A2, and so on, n attributes. Okay, and you have table S, where you have total m attributes. Then tell me, what will happen in R cross S? In R cross S, first you tell me what will be the attribute list. Very simple. This followed by this. Yes or no? Because every tuple of R will combine with every tuple of S. So remember, in R cross S, you will have A1 to AN followed by B1 to BM. Yes or no? So remember, every tuple of R will combine with every tuple of S. So tell me, in R cross S, what is the degree? Let me know. Let me know what is the degree of R cross S. What is that? That is equal to degree of R plus degree of S. Degree of R plus degree of S. Yes or no? Next, what about the cardinality? What is the cardinality of R cross S? That is equal to Remember, every tuple of R will combine with every tuple of S. So I can say that will be cardinality of R multiplied by cardinality of S. Okay, cardinality of R multiplied by cardinality of S. I can say that will be Mn. Sorry, number of tuples in R, number of tuples in R multiplied by number of tuples in S. Okay, is this clear? Actually, N is arity, N is degree of R. Okay, and M is degree of S. So actually, degree of R cross S will be M plus N. But here the cardinality will be number of tuples here multiplied by number of tuples here. Okay, is this clear? So very simple, these points. You can see. What about this situation? If you have same attribute name, for example, here AB, here BC, these two names are same. In this situation, what you will do? In this situation, what we will do? I want R1 cross R2. Here I have AB, here I have BC. You can see they have same name. So very simple. Solution is very simple. Here we will write R1 dot B, R2 dot B. But remember, there will be four attributes. Okay, four attributes, and these are the tuples. So remember, you can write R1 dot A, R2 dot A. If both of them have attribute A, if both the tables have attribute A, you can write R1 dot A, R2 dot A like this. If both tables have attribute B, then you can write R1 dot B, R2 dot B. Okay, in the cross product. Very simple. Okay, let's move on now. You can see here. Okay, here 4 attribute, here 2 attribute. In the result, there will be 6 attribute. And every tuple here will combine with every tuple here. Okay, and remember, UID here and UID here, they have same name. So actually what will happen? Actually what will happen here? Actually here, tell me what will happen? Here user dot UID. Okay, here you will write user dot UID. This will be user dot UID, and this will be member dot UID. Okay, simple. Now let's move on. So we have seen the cross product. All these details we have seen. Now let's move on. So you can see number of tuples in the cross product, that will be number of tuples in R multiplied by number of tuples in S. And degree in the cross product, that will be degree of R plus degree of S. Okay. And this is a binary operation. And it does not require union compatibility. Every point we have seen. Okay. Let's see some more points. These are simple set theory points. What about commutative? See, let's see commutativity. These are simple points. What about commutativity? Okay, can I say R union S? This will be same as S union R. Tell me. If only data is concerned, don't worry about schema. See, here the schema of R will be used. Here schema of S will be used. Do you agree? Do you agree? Here schema of R will be used. Here schema of S will be used. So assume only data is concerned. Okay, so assume only data is concerned. Only data is concerned. Now you tell me, if only data is concerned, which is the situation most of the time. Okay, remember, we only care about the data most of the time. We only care about data. So if data is concerned, then can I say that R union S, S union R, they will be same? Yes, they will be same. What about R intersection S, S intersection R? Yes, that is also correct. What about R cross S, S cross R? If only data is concerned, yes, all of them are correct. Okay, but now what about R minus S and S minus R? If only data is concerned, then can I say they will be same? No, they will not be same. Okay, they will not be same. If data is concerned, then also R minus S, S minus R, they will not be same. Okay, let me give you one example. Okay, for example, let's assume R has this attribute A, and let's assume you have 1, 2. Okay, and in S, let's assume you have attribute A and you have 1, 3. Now tell me what is R minus S and what is S minus R. Tell me R minus S is what? What is R minus S? R minus S means those values of R which are not in S. R minus S means those values which are in R but not in S. So this will be R minus S. What will be S minus R? Those values which are in S but not in R. Those tuples which are in S but not in R. Okay, so this will be. Did you notice they are different? Even the data is different. Yes or no? Even the data is different. So you can see that if only data is concerned, remember most of the time we only care about the data. Okay, so easily you can see that they are commutative, like union, intersection, cross product. They are commutative. If only data is concerned, if only data is concerned, okay, in the database, in the DBMS, we only care about the data, so they are actually commutative. Okay, but remember this set difference is not commutative. This is not commutative. Okay, is this clear? Simple, right? And what about associativity? And what about associativity? What about associative property? Tell me, associative property means like this. See, if I do R union S union T, first I do their union, or first I do, see, notice, okay, first I do R union S, okay, or first I do S union T, will the result be same? Will they give me same result? Yes, they will give me same result. Okay, so this is actually associative. Similarly, intersection is associative. If I do, let's assume intersection, for example, I do intersection of S T. Okay, if I do like this, then remember whether I do this first or whether I do this first, both are fine. Both are fine. Okay, in the cross product also the same thing will happen if only data is concerned. Yes or no? If data is concerned, then tell me about cross product. R cross S cross T. R cross S cross T. Again, the same thing will happen. Whether I do this, whether I do this, both will be fine. Okay. What about the set difference? Tell me, what about the set difference? If I do R minus S minus T, R minus S minus T, if I do this first or I do this first, will they give me same result? No, they will not give. Okay, they will not give. So remember, these are associative. In DBMS, they are actually associative because we only care about the data. Okay, this is not associative. So these things are written here. Okay, in this slide, you can see intersection, union, they are commutative, they are associative. You can see minus is not commutative. Okay, so all these things we have seen. Let's move on now. Cross product is commutative as long as data is concerned. You can see that as far as data is concerned, as far as data is concerned, then you can see cross product is commutative because we only care about the data. Okay, now a very small topic, that is rename operation. Okay, what is this rename operation and assignment operation? This assignment operation we have already seen, right? Yes or no? This assignment operation we have already seen. This is very intuitive, that you are assigning, okay, some result you have, that you are assigning to something. Okay, this result you are assigning, you are calling it by name S. Yes or no? This result you are calling it by name S. So this assignment is actually very simple. This we have seen. Now let's see this rename operation. And this rename is also very simple. Let's see this rename operation. First of all, the symbol. The symbol is row. Okay, this is the symbol. Okay, what is the name of this symbol? That is row. So this is the name of this symbol. Now, what is this rename operation? Remember, you can rename attributes. Also, you can rename table name. Okay, what we can do? We can rename table name. You can rename table name, or you can rename attribute names. Attributes. Okay, you can rename attributes, or you can rename both. Okay, we can rename table name, or we can rename attributes, or we can rename both. For example, if I want to rename table name, this is my table R. I want to rename this table with s. Then what I can do, very simple, I can do this row s, means basically this is renaming. Okay, is this clear? This is renaming. Now let me tell you one more thing. When you do this renaming, then it does not mean that the name will change. No, a new copy will be created. Okay, is this clear? When I say rename, when I say you are renaming a table, then the original table will not rename. A new copy will be created by name s. Is this clear? When I say rename, then it means that a new copy will be created by name s. Okay, so the original table will be as it is. The original table will not change. Okay, a new copy will be created by name s. So you can see, if I want to rename a table name, then I can do like this, that this table name I'm changing to s. Okay, very simple. So this is the rename. This row means rename. If I want to change attribute names, then what I can do, for example, let's assume my table is R and I want to change the attribute names, then very simple, I can put the attribute names here. Okay, let's assume R has A1, A2, A3, and I want to change them B1, B2, B3. Then I can do that. Okay, let's assume R has A1, A2. I want to change them B1, B2. Then I can do that. So this is attribute renaming. Okay. And the third, if I want to do both of them, then that is also fine. This is relation R. I want to call it S. And I also want to rename the attributes B1, B2. Okay. So all of them are fine. Is this clear? All these are fine. So this is a very simple topic. For example, let's assume you have a table R, which is A comma B. Okay. And let's assume I write this S R. Then what it will mean? It will mean I'm renaming the table. Yes or no? Is this clear? So here I am renaming table. Renaming table R to S. Okay. Next, if I say like this, for example, if I say E comma F R, now what it will mean? Let me know. Here I am renaming attributes. Here I am renaming attributes. Okay, I am renaming attribute A to E and attribute B to F. Okay, yes or no? And similarly, if I say SEF, now here both. Okay, renaming both. I'm renaming both. Very simple. And if I only want to rename one attribute, can I do that? If I want to rename only one attribute, can I do that? I want to rename only one attribute. Yes, I can do that. See, very simple. I want to rename this A. From this table R, I want to rename this A. So this, like this you can do that. A, change it to E. A, change it to E. Is this clear? Okay. Like this I can write. What it will mean? It will mean that basically A name is changing to E. Okay. Is this clear? Simple. Very simple. Okay. So like this also you can do. I hope you understood. So these are simple points. I hope all these are clear. So here I am renaming the table. Okay. This R renaming to S. Here renaming attributes. Yes or no? Here I am renaming both of them, S and attributes. Okay. So all these three things you can do. Okay. Here renaming both. Here renaming table. Here renaming attribute. Okay. So you can just easily check. You can see these are the three things: renaming table, renaming attribute. Sorry. Here renaming both. Here renaming table. Here renaming attributes. Okay. You can see, if I want to rename A to, okay, if I only want to rename A, then I can do like this, that I'm changing A to A2. Okay. Like this, you can see, for example, changing A to E, changing B to K. Okay. Changing A to E, changing B to K. Okay. So like this, you can do the renaming. Very simple. The renaming concept is actually very simple. You can see here, changing A to A1, changing B to B1. Okay. So like this, you can do the renaming. And R to S, changing R to S, A to A1, B to B1. So like this, you can do the renaming. Okay. Is this clear? Simple. So we have seen the concept of renaming, you can see. Okay, this type of renaming you can do. So we have seen all the basic operations. We have seen selection, projection, cross product, union, difference, renaming. All these we have seen. And we have seen intersection, but that is not basic. Yes or no? See, the basic operations are selection, projection, cross product, union, difference, renaming. Okay, there are how many basic operations? Let me know. How many basic operations? 6 basic operations on your screen. What this selection will do? It will select tuples. So it is doing horizontal partition. What projection will do? It will select attributes, or I can say it will project attributes. So this is vertical partition. Cross product, it will combine every tuple of this relation with every tuple of this relation. Union, we are doing the union, set difference and renaming. So these are the basic operations. We have also seen intersection, but this is not basic, this is derived. Okay, so all these points we have seen. I hope everything is clear. Please tell me, is everything clear? Let me know. In this session, whatever we have seen, did you understand? Let me know. Did you like this session? We have covered each and every important point. Let me tell you. Okay, for every operation, every important point I told you the important properties of selection operation, important properties of projection operation, and GATE 1998 question, a beautiful question based on projection, comma selection. Okay, so every important theorem, every important result, everything I have told you in this session. Okay, so we will continue in the next session. In the next session, we will see the derived operations. We will see join, we will see division operation. Okay, outer join, full outer join, basically all the remaining operations we will see in the next session. Okay, thank you everyone.